Assalamualaikum and hi everyone. So in this video we are still in chapter 2.1 Bohr atomic model, but I will cover learning outcome D and E. Okay. So describe the formation of line spectrum of hydrogen atom and illustrate the formation of Lyman, Balmer, Paschen, Brackett and Fun series. Okay, so over here, okay, saya ada salah sikit buat learning outcome. Okay, so saya termiss out learning outcome E. Okay, so ganti yang E ni dengan F lah. So that's mean learning outcome kita up until K. Okay, so first let us look at two different types of emission spectra. Okay, there are two types of emission spectra, continuous spectrum and line spectrum. Okay, so from the learning outcome, we are supposed to learn line spectrum. Tapi saya ajar jugalah continuous spectrum ni briefly so that kamu boleh bezakan macam mana apa continuous spectrum, apa line spectrum. Okay, so continuous spectrum is a spectrum that consists all wavelength component containing an unbroken sequence of frequencies of the visible portion of electromagnetic spectrum. Okay, so example dia dekat sini lah. Okay, kamu boleh tengok. Saya dah label dah. This is an example of continuous spectrum. Kiranya kamu dapat continuous je. Frekuensi dia tu ataupun wavelength dia tak putus-putus. Dia bersambung sahaja. Dia macam rainbow tu lah. Okay, and then untuk line spectrum pula, kamu boleh nampak yang bercolor ada certain line je yang ada color kan. Okay, so maksudnya untuk line spectrum dia ada dia punya frekuensi and wavelength dia tak continuous, tidak bersambung tapi dia discrete. Okay, nanti kita tengok lah specifically line spectrum. For now, just remember continuous spectrum, dia punya wavelength and frekuensi dia sambung straight je dia. Okay. Right, and then it is produced by incandescent, solid, liquid and compressed gas. Okay, continuous spectrum. Cara paling senang nak hasilkan, kamu bayangkan kamu ada apa tu prism. Lama dah saya tak pandai nak lukis sangat. Okay, let's say lah you shine light dekat prism tu. Okay, and then prism tu akan hasilkan ni lah rainbow ni. Okay, so itu cara menghasilkan continuous spectrum. Okay, so let us look at line spectrum yang lebih penting. Okay, line spectrum is a spectrum consists of discontinuous and discrete line produced by excited atoms and ions as they fall back to a lower energy level. Okay, so line spectrum ni dia dah cakap dah discontinuous. Okay, which is opposite to continuous spectrum. Continuous spectrum continuous lah. Ini discontinuous, that means dia tidak bersambung. Dan dia ada discrete line. Okay. Discrete line tu maksudnya referring to this one lah. Ini line ni. Okay. So discrete line. And macam mana line ni terhasil? Line ni terhasil apabila electron from a higher energy level fall to lower energy level. Okay. So bila electron fall kan kita dah belajar. Dia akan release energy in the form of light. Okay, so energy in the form of light tu kan ada specific frequency and wavelength. So itulah yang menghasilkan line ni. Okay. Right, then next dia kata the radiation emitter is only at specific wavelength or frequency. Ya, saya dah cakap tadi. It means each line correspond to specific wavelength or frequency. Okay, so kita boleh tengok this energy level diagram. Sorry, this one energy level diagram. Okay, and this is line spectrum yang kita baru cakap ni. Okay. For your information, energy level diagram and line spectrum tak sama. They are not the same thing. Okay, dia nampak sama tapi dia tak sama. Okay, so over here, let us look. Okay, so this is line spectrum. Okay, and dia dah bagi guideline dah over here. As we go from left to right. Okay, left to right. Kita dia punya lambda which is wavelength dia akan makin meningkat. Okay, so kiranya wavelength tu lagi tinggi lah yang sebelah kanan. Okay, compared tu yang sebelah kiri. Okay, lepas tu kita tengok sini. Ini adalah energy level diagram. So let's say lah we have electron. Okay, and the electron fall from n equal to 2 pergi ke n equal to 1. Okay, so we know that when the electron fall, dia akan release energy. Okay, with a specific frequency or and wavelength. Okay, so maksudnya dia ada specific. In this case kita guna wavelength lah sebab data kita bawah ni adalah wavelength. So let's say lah elektron ni release energy sebanyak tu, and then dia ada specific wavelength dia, so mungkin wavelength dia dekat sini. Okay, so this is the first line yang terhasil. Okay, but then kita ada second electron pula, dia fall from n equal to 3 to n equal to 1. Okay, so bila dia fall macam ni, so dia punya frekuensi ataupun dalam kes ni dia punya wavelength lah. Okay, dia punya wavelength adalah dekat sini nilai dia. Okay, so dia dekat situ. And then kalau kita ada elektron lagi, and then the electron fall to n equal to 1, dia punya lambda dia adalah yang the next one ni. Okay, line dia. Okay, and the last ni adalah line yang hujung ni. Okay, so from this equation saya tahulah, okay, since this one delta E dia paling besar, so maksudnya line yang akan terhasil tu adalah line yang berada pada wavelength yang paling rendah lah, which is this one. Okay, alright, so adakah benda ni benda yang sama? Tak, dia tak sama. Okay, so ini energy level diagram just show electron transition sahaja. Okay, but for line spectrum dia lebih spesifik, dia boleh show frekuensi atau wavelength. Dalam kes ni dia boleh show wavelength tinggi arah mana, energy dia macam mana. Okay, so line yang terhasil ni bukan saja-saja kita boleh lukis, dia terhasil dekat tempat wavelength tu. Okay, alright, so let us read apa yang saya tulis kat bawah ni. Radiant energy or quantum of energy absorbed by the atom causes the electron to move from lower energy state to higher energy state. Okay, so this one dah kali keberapa kamu dengar. Okay, when electron, okay, absorb energy, that means it will move from lower to higher energy level. Okay, and then we know that when the electron move from lower to higher energy level, this higher energy level here specifically kita panggil sebagai excited state. Okay, and we already know that electron at the excited state is unstable. Okay, so the electron dekat excited state is unstable. So bila electron at excited state unstable, so this electron will fall back to lower energy level. Macam ni, n equal to 2, so dia akan fall to n equal to 1 je lah. Dia tak ada option. Tapi let's say lah we have electron transition from ini dia pergi ke n equal to 4 katakan. Okay, and then ini adalah excited state for this case lah. Okay, n equal to 4 is the excited state, and then the electron is unstable at excited state, then the electron will fall back. Okay, so the electron can fall back to n equal to 2 only pun boleh. Dia nak fall back to n equal to 3 sahaja pun boleh. Depend pada energy dia lah. Okay, and then when dia fall back, dia akan release energy. Okay, and release energy tu in the form of light, and then with a specific frequency or wavelength. Okay, so basically apa yang saya cakap ni adalah cara untuk menghasilkan line spectrum. Okay, so kalau soalan tanya how to produce line spectrum, you have to start cerita daripada point number 1, 2 and 3. Okay, so you have to start daripada energy at ground state tu, absorb energy, pergi excited, unstable, turun balik, release energy. So kena cerita balik. So basically apa yang kita cerita balik adalah postulate number 3 dan number 4. Okay, so itu adalah cara menghasilkan line spectrum. Okay, so next, from the learning outcome, you should be able to illustrate the formation of Lyman, Balmer, Paschen, bracket and Fan series. Okay, so macam mana nak tahu series-series ni macam mana, bila terjadinya series ni? Okay, so sekarang kita tengok lah. Okay, so let's say lah, okay, ini adalah energy level diagram lah. Okay, so let's say lah we have electron from n equal to 2 and the electron fall to n equal to 1. Okay, that means dia release energy lah. Okay, so let's say we have another electron at n equal to 3, then the electron also fall to n equal to 1. Let's say we have another electron n equal to 4 and then fall to n equal to 1. So basically tak kisahlah where the electron come from, as long as the electron fall to n equal to 1, that means itu adalah Lyman series. Okay, Alright, so saya dah tulis dah. When the electron fall from excited state to lower energy state of n equal to 1, that means dia adalah Lyman series. Okay, that means series ni depend on tempat elektron tu fall. Bukan dari mana dia datang, tak kisah. Okay, alright, so next kita tengok yang up sikit, Balmer. Okay, so Balmer, tak kisahlah elektron tu dari mana, as long as the electron fall to n equal to 2, that means itu adalah Balmer series. Okay, and sama jugalah Paschen, that mean n equal to 3. So maksudnya elektron tu fall to n equal to 3 Paschen. Bracket pula, tak kisahlah elektron tu dari mana, tapi dia fall to n equal to 4, that mean dia adalah bracket series. Tapi obviously kalau bracket series, elektron tu kena fall to n equal to 4, that mean elektron tu paling tidak pun kena datang daripada n equal to 5 and above lah. Okay, for fun series, okay, the electron must fall to n equal to 5. Okay, saya tak tulis sini tapi dia mesti fall to n equal to 5. Okay, alright, so itulah series-series yang kamu kena tahu dan kena ingat. Okay, so cara nak hafal dia, saya ikutlah Lyman, balik, pasar, break, putus pun boleh. Okay, so Lyman, balik, pasar, break, putus, or bracket. Adalah lagi cara hafal yang lain. Okay, tapi inilah yang selalu saya guna. Lyman, balik, pasar, break, putus. Okay, alright, Lyman here means Lyman lah. Ini cara kita nak ingat. Okay, balik is Balmer, Paschen is pasar. Okay, break tu adalah bracket, putus tu adalah fun. Okay, so macam kenapa kita nak kena ingat? Ialah kita nak kena hafal ni. Okay, so Lyman, balik, pasar, break, putus. So kamu kira lah dengan jari kamu. Lepas tu kamu tahulah n dia n1, 2, 3, 4, 5. Dia tak ada start from 0, tak ada Okay, so the next thing, okay, kita tengok table ni. Okay, so in this table basically dia cakap series lah. Okay, kalau saya mention series, that's mean Lyman, Balmer sampailah fun tu. Okay, and then N1 ni that's mean dia datang daripada, dia turun ke mana lah. Okay, so datang daripada mana, macam Lyman, all the electron must fall to n equal to 1. That's mean that electron can come from 2, 3, 4, 5, 6, 7, 8 sampai infinity lah electron tu boleh datang. Okay, alright, itu maksud dia dekat sini lah. Contoh, let's say lah bracket series, that's mean n electron tu must fall to n equal to 4. Where the electron come from? Electron must come from n equal to 5, 6, 7 and above lah. Okay, takkanlah dia nak fall tu jatuh. Dia nak jatuh ke n equal to 4. Takkan dia dari n equal to 3. Salah lah kan. Okay. Alright. And then another thing, this one. Okay, very, very, very important juga. Okay, spectrum region, or sometimes dia panggil region of electromagnetic spectrum. Okay, depend on the question. Ataupun boleh tambah lagi. Sometimes ada dia bagi sebagai radiation region. Okay, so kalau soalan kata state the radiation region for Lyman series, that mean UV. Kalau dia kata state the electromagnetic spectrum region for Paschen, that mean infrared. Okay, right. So basically ini maksudnya transition ini berlaku dalam spektrum ini. Okay, spektrum ni kamu dah pernah belajar kan dalam fizik, ada kan, tak silap saya. Okay, so dalam spektrum tu contoh dalam UV. UV dia ada spesifik frekuensi dia dari mana ke mana. Visible pun sama, frekuensi dari mana ke mana ataupun dia punya wavelength dia. Okay, so maksudnya series ni dia terjadi dekat spektrum mana. Macam itulah lebih kurang. Okay, and then how to memorize? Senang je. Saya hafal macam ni je. Lyman, UV. Okay, Balmer, visible. The rest, saya tak hafal dah. The rest, saya ingat IR. Okay, so maksudnya kamu hafal 2. Lepas tu yang lain tu kamu ingat, oh semua tu, yang lebih-lebih tu adalah infrared. Okay, so next, kita tengok example. Okay, so the following diagram depicts the line spectrum of hydrogen atom. Okay, so this is line spectrum. Line A is the first line of the Lyman series. Okay, so line A dia dah cakap first line. Okay, so kita label lah sikit first line. Okay, tapi let's say lah soalan tak cakap first line. Okay, saya nak bagi tips kat kamu. Cara nak identify first line adalah dia punya gap ni paling besar. Okay, the biggest gap, the first line is the first line lah. Macam tu pula cakap dia. Okay, so line yang pertama tu adalah line yang first. Okay, dan and then next apa lagi dia bagi? Oh, ini ada ni. Tapi color dia agak tak terang. So, jom kita label lain. Okay, ini actually frequency dia increase. Lambda dia decrease. Energy dia increase. Okay, so maksudnya going from left to right, frekuensi dia makin meningkat. Lambda dia makin menurun. Okay, manakala dia punya energy makin meningkat. Okay, so saya tahu nanti kita akan confuse. So, better kita tulis lah. Okay, so kita tulis going from left to right. So, maksudnya dia punya frekuensi dia akan increase. Okay, going from left to right, dia punya wavelength dia akan decrease. Okay, and then going from left to right, dia punya energy akan increase. Okay, so that bila kita tulis, otak kita cepat tangkap sikit. Okay, so next kita tengok specify the increasing order of radiant energy, frequency and wavelength of the emitted photon. Which of the line that correspond to the shortest wavelength? So the question asks us which of the line A, B, C, D, E ni yang wavelength dia paling rendah. Okay, so dekat sini dia dah bagi clue. Wavelength paling rendah adalah yang ke kanan. Okay, makin ke kanan wavelength makin rendah. So that means our answer here should be line E. Okay, so line E adalah line yang paling pendek wavelength. Okay, okay, so next question minta which line yang lowest frequency. Okay, so kalau kita tengok ni daripada left to right, frekuensi dia akan meningkat. So kalau nak cari yang paling rendah, that's mean opposite direction lah, which is line A. Alright, so line spectrum, okay, dia boleh dalam dua bentuk lah. Okay, so first bentuk yang ini, okay, pun boleh. That's mean gap yang besar tu di sebelah kiri, start dari kiri. Okay, kalau kita tengok line spectrum yang tadi, which is this line spectrum, the biggest gap is sebelah kanan. Okay, so tak kisah mana-mana, betul je. Cuma this one, where is the first line? Okay, the first line adalah inilah, ini first line sebab dia biggest gap dan yang paling hujung sekali adalah first line. Kan? Right, so next let us move to example 2. Right, so example 2 dia kata describe the transition of electron that lead to the formation of line W and Y. Okay, so dia bagi line spectrum and this line spectrum is in Balmer series and dia suruh kita specific transition yang menghasilkan line W and Y. Okay, transition here means the question asks us to tell the electron fall from apa level pergi ke level apa untuk menghasilkan line W dan line Y. Okay, kenapa fall? Kenapa bukan naik atas? Sebab tadi kan kita cakap bila elektron fall from higher energy level to lower energy level, itu yang release energy tu with a specific frequency and wavelength. Okay, itu yang menghasilkan line tu. Okay, right. So sekarang dia bagi tahu this is Balmer series. Okay, Balmer series that mean n equal to leman balik. Okay, leman balik 1, 2. So n equal to 2. That means all the electron will fall to n equal to 2. So barulah kita panggil dia Balmer series. So cara dia, saya akan label 2 to 2 dekat bawah ni. Okay, and then elektron tu mestilah paling tidak pun come from n equal to 3 lah. Baru dia boleh fall to n equal to 2 kan. Sebab dari atas turun ke bawah. Okay, so tapi masalah dia, where is the first line? Okay, mana first line? First line dia dekat mana? Okay, so first line dia sebenarnya kan tadi saya cakap cari gap yang paling besar. Okay, which is this one, gap paling besar. And then the first ni adalah first line dia. Okay, so maksudnya ini first line. Okay, label sikit lah. Ini first line. Okay, since the first line, so that's mean ini 3, 4, 5, 6, 7. Kenapa saya label macam tu? So maksudnya line ni terhasil apabila elektron fall from n equal to 3 to n equal to 2. Okay. While the next line is formed when electron at n equal to 4 fall to n equal to 2 and so on lah. Okay, so dia suruh kita describe the transition of electron that lead to the formation of line W and Y. So, kita dah dapat answer. Line W is actually transition from n equal to 4 to n equal to 2. While line Y is formed when the electron fall from n equal to 7 to n equal to 2. Last example, okay, which is example 3. The question asks us to calculate the En for n equal to 1, n equal to 2, 3, 4, and then make one-dimensional graph showing energy at different values of n increasing vertically. On this graph, indicate the vertical arrow transition that lead to the alignment series dan partition series. Okay, so over here, kita kena calculate ni dulu. Okay, satu. Lepas tu kena buat graph. Okay, so kita settlekan yang the first one dulu. Okay, so to calculate energy at specific energy level, okay, we need to use this formula, ingat. And then substitute je lah. N equal to 1, gantilah. Okay, and then saya dapat this value, that's mean electron at n equal to 1, the energy is banyak ni. Okay, and then at n equal to 2, this is the energy of electron, n equal to 3, ini energy electron, n equal to 4, ini energy electron. Okay, so settle untuk the first one. Next, kita nak buat graph. Okay, dan saya dah siap dah lukis one dimensional graph tu. Okay, ini graph yang dia maksudkan sebenarnya. Dia nak minta energy level diagram tu sebenarnya. Okay, energy level diagram. Okay, so as you can see, energy level diagram over here energy lah. Actually specifically potential energy sebenarnya. Okay, but then ini semua adalah energy level. Okay, so energy level must start from n equal to 1. Okay, tak ada n equal to 0, tak ada. Okay, and then another thing, kalau kamu perasan tak gap saya ni, saya draw, the gap is getting smaller. Okay, so this is how you should draw energy level diagram. Okay, you have to make sure the gap between the energy level tu getting smaller. Dia makin naik atas, the gap is getting smaller. Mesti buat macam tu. Okay, and then this one atas ni sebenarnya saya cuba untuk draw this line, okay, bagi dia rapat-rapat macam tu, so that kita boleh tunjuk lah itu n equal to infinity. Okay, tapi terketar-ketar sikit tangan, so jadi macam tu. Okay, so tak apa, so kita baru siap graph punya bentuk je dulu, kita belum label lagi sebab dia kata on this graph indicate by vertical arrow, that's mean arrow yang menegak, transition that lead to line, alignment and partition. Dia suruh kita tunjuk line yang transition yang menghasilkan line di dalam alignment dan partition series. Okay, so kita ingat balik alignment n equal to 1, alignment balik pasal 1, 2, 3. Okay, so n equal to 3. Okay, so kita nak draw, kita boleh guna color lain lah. Okay, kita guna color lain. Okay, so let's say lah we want to form alignment series dulu. Alignment series that means all the electron must fall to n equal to 1, which is this line. So tak kisahlah dia dari mana, dia dari 2 pun boleh, dari 3 boleh. So dia suruh kita draw je. So kita draw je lah. Okay, so let's say I want to draw this one. Okay, so that is the first line and then another. Okay, so ada lagi transition from n equal to 3 to n equal to 1, n equal to 4 to n equal to 1 also can. Okay, so n equal to 5 to n equal to 1 pun boleh. Okay, so dia tak spesifikkan berapa banyak line. So saya stop dekat situ je lah. Kalau nak tambah lagi pun boleh, tak ada masalah. Okay, alright. Cuma kita kena label lah. So inilah yang menghasilkan alignment series tu. Sebab bila dia fall to n equal to 1. Okay, then dia suruh kita draw line yang terhasil di dalam partition series. Okay, so partition 3. So maksudnya elektron tu dari mana? Okay, so let's say lah kita nak 3, maksudnya n equal to 4 turun n equal to 3 pun dah boleh menghasilkan line in partition series. So n equal to 5 to n equal to 3 also can, n equal to 6 to n equal to 3, n equal to 7 to n equal to 3. Okay, so this one akan produce line in partition series. Okay, so basically itu sahaja yang dia minta kita buat. Okay, I think that's all for example 3. Okay, thank you, bye.